This is 1.1 rectangular coordinates. Okay, this is the first section in chapter 1, and I'm going to let you know ahead of time for chapter 1. All the topics except maybe one are going to be from Algebra 1, Geometry, and Algebra 2. So this is review, and I'm going to trust that you're going to take notes on whatever you feel you need to have notes on. And if you feel very confident and you don't take notes on this topic, I'm okay with that because this is all review material. Okay, in section 1.1, they're going to introduce the coordinate plane, the xy plane. They're going to show you the distance formula and the midpoint formula, which are both familiar from Geometry and Algebra 2. Okay, and if you're handwriting these, just pause so you have time to write. If you like this typed out ahead of time, I'll put a blank copy on the calendar, which is posted on Canvas. Okay, the coordinate plane is the one you learned in, I don't even know what grade you learned it in. Okay, it looks something like this. This is the x-axis. This is the y-axis. If you're plotting an ordered pair in the real xy plane, it goes x comma y. So I would go to the side x and I would go up y depending on the x and y value. The point in the middle is called the origin. That point is also 0, 0. The coordinate plane is divided into 4 quadrants based on the x and y axis divisions, and it goes counterclockwise from the top right. Okay, so this is quadrant 1. We normally use Roman numerals, although I'm fine if you use the numbers you're used to. This is quadrant 2, and this is quadrant 3. Quadrant 4 is down here. Okay, right here it's I'm going to show you what the Pythagorean theorem is, which you definitely remember from Algebra 1 or from Geometry. That was not on the list of topics, but the distance formula and the Pythagorean theorem are essentially the same. And if you remember that, it does help you remember which formula you're referring to or figure out the distance if you forget. Okay, the Pythagorean theorem applies to a right triangle. There's my little right angle. Hypotenuse is length C. The legs are A and B. And then the formula you normally learn is a squared plus b squared equals c squared. Okay, why did I show you that right before I'm going to tell you the distance formula? Okay, the distance formula is trying to find the distance between 2 points. If I look at the triangle over here, if I consider this my point and this my point, I'm trying to find the distance from here to here. I'm basically trying to find C. Okay, so the formula is based on the fact that I'm trying to find the hypotenuse, which is a squared plus b squared equals c squared. Okay, if I go along the leg A, that's the horizontal distance. Okay, so if I look at the points, horizontal, if I want the distance from x1 to x2, I just subtract them. Okay, that gives me the distance along the side A, and I would square it because I'm using the idea of the Pythagorean theorem. Okay, if I want to find b squared is the vertical distance. y1 and y2 are representing the locations of the vertical distance. If I want the vertical distance from y1 to y2, I could just subtract them. So y2 minus y1 would give me the distance, and then I would square it. This would give me the distance squared. Okay, because they want to give you it in terms of d, instead of saying equals d squared, they square root both sides. This is the distance formula. Okay, so for the first example, we're going to find the distance between the points -3, 7 and 7, 5. Okay, I'm going to go ahead and use the formula. Often we use little d to represent d. The distance is going to be the square root of, and then I'm going to subtract the x coordinates. So this one and this one. Because we're squaring it after, the order I do this actually does not matter. So I'm doing 7 minus -3. And then I'm squaring it, and that's going to give me the x distance. Okay, then I do the y2 minus y1. Okay, I am going to do it in the order the formula indicates, but it actually doesn't make a difference because once you square it, it turns positive. Okay, let's evaluate this. Let's see, this is 7 minus -3 is 10 squared. 5 minus 7 is -2 squared. Do put a parentheses on your negative because you're squaring the negative as well. So what is that? That's 100 plus 4, which gives me the square root of 104. If they ask you to round it, you would just put it in a calculator. If they wanted an exact form, we're going to leave it with a radical. And if possible, I am going to simplify this. That looks like it divides it by 4. So if I divide by 4, that's 4 times 26. So this is actually 2 square root 26 in exact form. Okay, go ahead and find the U try problem. It says find the distance between the points 7, negative 4 and 12, 8. Pause your video while you do it, and then I'll give you the answer after so you can check. Okay, for my final answer, I got the distance to be 13. I'll do that real quick for those of you who would like to see it. And the square root of 169 is rational, which means the distance is just 13. Okay, let's look at the next example. The next example says show that the points 4, 0, 2, 1, and negative 1, negative 5 are the vertices of a right triangle. Okay, for something to be a right triangle, it does need to satisfy the Pythagorean theorem, which I know is a squared plus b squared equals c squared. In order to check if a squared plus b squared equals c squared applies here, I am going to need to find the lengths of each of the sides. So I'm going to use the distance formula to do that, which kind of means I'm incorporating both of the formulas into one problem. Okay, and given that the Pythagorean theorem and the distance formula are essentially the same, I could also use the Pythagorean theorem to do this. Okay, so I'm going to find the length of the leg that goes from 4, 0 to 2, 1. So d equals... Okay, let's do x minus x is 2 minus 4, negative 2 squared. I did skip the first step, and I'm okay with you doing the same. 1 minus 0 is 1 squared. So that's going to be 4 plus 1, which is root 5. Looks good. Okay, let's find the length of another leg. This is a triangle. There should be 3. Let's go with 2, 1, and negative 1, negative 5. Let's see. In the x direction, negative 1 minus 2 is negative 3. Negative 5 minus 1 is negative 6. Okay, and if you're getting the opposite sign, that's fine, because once we square things, they come out to be the same answer. What is that, square root of 45? Okay, and then the last side of the triangle is going to be from 4, 0, and negative 1, negative 5. So in the x direction, negative 1 minus 4 is negative 5 squared. And then in the y direction, negative 5 minus 0 is negative 5 squared. So I'm going to get square root of 50. Now, before we continue, a couple things. First, square root of 45 and the square root of 50 do simplify. But since that's not going to be my final answer, it may not be advantageous for me to simplify those right now. In fact, it'll be easier for me to leave them as they are at this moment. Okay, I just need to check if these lengths satisfy the Pythagorean theorem, but they did not actually tell me which one is the hypotenuse. But the hypotenuse is always the longest side of the triangle. So if I compare root 5, root 45, and root 50 must be the hypotenuse because it is the longest side of the triangle. So there's my C right there. Okay, so if that's my C, then let's just check. If I do root 5 squared plus root 45 squared equals root 50 squared, if this is in fact a right triangle, this should work. Okay, and I can see right here where it was nice to not simplify my radicals, because root 5 squared goes to 5, root 45 squared goes to 45, and root 50 squared is just 50. So this does check. So these were the vertices of a right triangle. Okay, the last formula in this section is the midpoint formula. If I want to find the midpoint of the line segment with endpoints x1, y1, and x2, y2, I'm really just trying to find what's the exact middle of the x-coordinates and what's the exact middle of the y-coordinates. And my answer should make sense, and it should be an ordered pair. So if I do want to find the exact middle of the x coordinates, I would add the x coordinates and divide by 2. That'll give me the middle. For the y coordinates, I do the same thing. I add them and divide by 2, and then at the end, I would look at my answer and say, does that make sense with the given points? Okay, so for this example, I'm just going to apply the midpoint formula. Okay, find the midpoint of the line segment joining the points 1, 2, and 7, 9. So I'm trying to find the point that's exactly in the middle of 1, 2, and 7, 9. Okay, I'm going to use the formula, and then I'm going to look back at the problem to make sure it makes sense. And say, in the x direction, I want to find the middle of 1 and 7. So I'm going to do 1 plus 7 over 2. Okay, 1 plus 7 is 8. 8 divided by 2 is 4. Okay, before I move on, I'm just going to look. Does it make sense that 4 is between 1 and 7? Yes, it's exactly between 1 and 7 because that's the whole point of the formula. Okay, I'm going to go in the y direction. I got 2 and 9, so 2 plus 9 divided by 2. This will give me the exact middle of in the y direction. So that's 11 divided by 2. I'm going to leave it as 11 over 2. But I might want to consider this as a mixed fraction just to confirm my answer. 11 over 2 is 5.5 or 5.5. Is 5.5 between 2 and 9? Yes, it's exactly between 2 and 9, which is why it is a midpoint. Okay, go ahead and try this last one. It says you try the endpoints of the diameter of a circle are -11, 5, and 3, -7. What is the center of the circle? Go ahead, pause the video. I'll tell you the answer when you're done. Okay, for your final answer, you should have gotten -4, -1. I will go over it in case your answer didn't match up. Okay, let's see. The center of a circle, I'm going to use C for center. It doesn't really matter. It's up to you. Okay, but I'm still using the midpoint formula because if the endpoints of the diameter are at -11, 5, and 3, -7, the center of the circle is exactly between them. Okay, so let's see. In the x direction, I have -11 and 3. I'm going to add them and divide by 2 to find the center. Let's see, what is that? -8 over 2. I got -4 for the x coordinate, which makes sense because -4 is between -11 and 3, exactly between them. Okay, in the y direction, I have 5 and -7. Okay, and the order you write these doesn't matter because we're adding them. Okay, what is that? -2 over 2, which is -1. In the y direction, -1 is between 5 and -7, so the center of my circle is -4, -1.